Okay, so far we've only worked with right triangles. Pythagorean theorem, your sines and cosines and all that works great. So we're going to solve some oblique triangles. That would be any triangle that's not right. There are 4 cases. You don't really have to memorize the cases. I don't really have them memorized either. I just know how to apply the stuff that I'm going to show you. And then hopefully with a little common sense you can figure out like the differences between some of the cases. So today we're only going to look at what if I know one side and 2 angles. Okay. In general, if you want to solve a triangle, only 3 things have to be known out of the 6. Keeping in mind that this triangle has 3 angles and 3 sides. If you give me 3 of those, then I can solve the triangle. I do need to know at least one side. Okay? So let's move on. To do that, we use what is known as the law of sines, at least for what we're doing today. And I think that you ought to be able to sort of derive the law of sines, which this is very similar to what the bell work would have been if you had actually solved it, but now we're going to solve this thing with all unknowns. So I'm labeling my triangle in terms of the parts of the triangle. So angle A, side A, angle B, side B, angle C, and side C. Then I'm going to do what Crystal suggested I do earlier, which was make a line perpendicular. So split it into 2 triangles. Okay, creating the right triangle so that I can use my sines, cosines, and tangents and all those. And then this little line from C down to C, that would be called the height of the triangle, right? Okay. And then I can actually write some stuff here. So, for example, if I stood in angle A, and this is the law of sines, so let's look at what would the sine of A be. Well, the sine of A is what? H over B. Okay, so let's solve that for H. So this is then similar to those problems that we did with the height of the mountain, sort of. So the height of the triangle has to be B times the sine of A. Are you guys okay with that? Let's go stand in angle B. What is the sine of angle B? In H over A, right? Okay. So that means that your height is also A times sine of B. Is everybody okay with that? Well, if they both equal your height, then this has to be true, right? B times the sine of A has to be equal to A times the sine of B. That's sort of an ugly way of trying to memorize the law of sines, because that's sort of confusing. So let's line up things that have A's on one side and things that have B's on the other side. And you can do this different ways. So if I do this, if I say A divided by the sine of A, so if I divide out by the sine of A here, that cancels, right? And then on this side, I'm going to divide by the sine of B, so those cancel. Then this would be a much friendlier way of trying to memorize that little law, because now look what happens. The angle and the side are on the same side, so side divided by the sine of the angle is equal to side divided by the sine of the angle. And this is the law of sines. Now we're only missing one part of it here, and that would be that you can also do this with C. If I just rotate A's, B's, and C's around, would you believe, just on faith, that you could also come up with this one? I mean, I chose what I called A, B, and C, right? If I just choose a different A, B, and C, but draw the same triangle, do the same stuff, then I'll just swap out my A's and B's and C's, and I can get that one as well. Okay, so that's the full law of sines. It's just that the ratio of the side relative to the sine of the angle is constant in a triangle, in any triangle. This actually works for right triangles too. So how can you use this to solve a triangle? So here's a triangle. We are given that angle A is 32. lost my marker. So angle A is 32. Angle B is 81.1. Sorry, 81.8. And A is 42.9. So where's the 42.9 go? Okay, good. Okay, so how can I solve this triangle? Well, one of the things should be easy to solve. That would be the missing angle. How do you find the missing angle? Minus the other two, right? Okay, so add those two together, subtract from 180, and that should give you C as 66.2. So that was easy. Okay, the other side lengths are a little bit harder to find, and I can't use Pythagorean theorem because they're not, I don't have a right triangle, and I don't want to do what we looked at for the Bellwork because that's way too long. So what we want to use is we want to use somehow the law of sines. So I'm going to write down all three of them. Okay, I'll just do this for this problem only. And then after this, we're just going to work with it with the ones that we need. So out of the three ratios, which one do I have completely? So for which one of these do I have both of the parts? The first one. So you definitely want to use, so in case you're wondering, why is he using the 42.9 and the sine of A? Well, that's the only combination that I have, right? Okay. Let's label this side as B, because that's across from B, and this side as C. Well, which one do you want me to find first? Sarju? B? Okay. Well, B is unknown, but do you know angle B? Yeah, so out of the four unknowns, we know three. So can we solve this? Yeah, so we're just going to do that, cross multiply this. So the sine of 32 times B is equal to 42.9 times the sine of 81.8. So how do you find out what B is? Yeah, divide this mess. And so this is what goes in my calculator. I don't figure out what the sine of 32 is yet. I just want to know what do I need to shove in my calculator to get an answer for B, and B would be what? I forgot to write down what B is. Can somebody do it? Tell you it needs to be more than 42.9. 80.12-ish?
That's what I wrote there.
Okay, we'll round it to 80.1. Okay, what am I missing still? Okay, I would use the same one, because this is the only one where, like, I haven't done any rounding for A and sine of A, right? So set up the same proportion, but in this case it's C over the sine of 66.2. And I'll show you what I actually end up writing down. So if you cross multiply, then you multiply these two, right? And you end up dividing by the sine of 32. And then you put that in the calculator and you should get an answer. How much? 74? Okay, 74.1. Is that okay if I write 74.1? Okay. Common sense check here. What can I do to make sure that it at least feels right? So smallest angle, smallest side, right? Largest angle, which is B. So B should have the largest side. Is B the longest? Okay, so I feel good with this. Okay, so if you're not really sure and you want to check, this is a quick way that you have a common sense check, sort of. Okay.
Wait, we're finding big C or little c now?
Well, I already found big C, right? Capital C was found over here. Yes?
Little c,
No.
big
That's.
C?
Keep in mind, capitals stand for angles, right?
I know, but what's the same?
I know, but I did put a degree on here. Yeah? And I did not put a degree on the 74.1. So the 74.1 is a length. I understand that it's a little confusing. A and B are a little easier to distinguish because they don't quite look the same. But okay, last problem. Word problems are usually better in these because you don't have to find every single part of a triangle to solve the word problem. So let's see what we are given. So we are given that the distance from A to B is 14.98. You may not be able to, well, you can't see that either, but I can fix that. Wow, 1,498. You're right.
What is that supposed to be?
It's actually a picture of a river up in Idaho somewhere, I think. So, imagine that you wanted to build a bridge across the river. How long would this bridge have to be is sort of the idea here. And a lot of things you can measure in here. I mean, you can measure the angle here at A. So you just drive a stake in over here, and you drive a stake in over there, and just measure that angle relative to B. So you put, you know, 3 things. You mark 3 things here. You can go out and measure the angles. We know that angle A is 82 and B is 60, and we want to know what? Which out of these do we want to know?
We want to know AC.
Yeah. So I'm just going to put the X over here. So X lines up with which one? With B. So you have one ratio, right? Like we know we have one ratio where we have an unknown, sorry. And what is the only ratio that we do know?
We can figure out C if we...
Right. So we need to find the sine of C, because that matches the 1498. So how much is C in this little story?
C is 38.
Okay, so plug that back into your ratios. So X will be 1,498 times the sine of 60. Why can't I use a special triangle here? That's 60 degrees.
Yeah, but there's no right angle.
No right angle. Okay, and this sort of purposely picked one with a angle that you might be familiar with, but you can't go back to that ratio because it's not a right triangle, right? So good. This one I actually do have the number. And feel free to check that, because I do make mistakes. But here, we didn't have to solve for all the sides, just one side. Fortunately, finding one angle is pretty easy when 2 are given. So, not a super difficult word problem. D. I'm again on duty on Saturday.